All right, hello all. This is Dr. Alsop again, and in this video, we will be discussing factors that affect bone. So really what we're getting into are the specific structures such as minerals, vitamins, hormones that can play a role in terms of bone resorption or bone deposition, but also importantly, bone remodeling. So we talked a little bit about that in a previous video, so let's talk about these specifics in a bit more detail. Okay, so you can't talk about this without obviously talking about the minerals that are playing such a huge role here. And this should really make intuitive sense. We know that we really can't have that extracellular matrix without these important minerals. In particular, and that's why I have an asterisk here, is calcium. Calcium is going to play a huge role, with phosphorus playing a lesser role. And I do have a few other ions here, magnesium, fluoride, manganese, that will play a much smaller role, but it's really these two that I want us to remember are going to play a role. So you're going to have these kind of stored within bone, and then in certain scenarios, either it's going to stay stored within bone or it could be released from bone to increase blood calcium levels. So we'll talk about some of the things that will cause that to occur in a moment. So really focus in on these two here. Okay, now let's move on to vitamins now. And vitamins are going to be very important. There's more than just the two that we're going to talk about that will play a role, but I really want us to focus in on vitamin C as well as vitamin D because they're going to play the bigger roles. Okay, so let's start with vitamin C. This is needed for the production or the synthesis of collagen. And we know collagen is hugely important as the organic material that's going to play such a big role in terms of the extracellular matrix. So if you have an insufficiency of vitamin C, that can have pretty great effects in terms of bone growth or even delay in terms of fracture repairs. So vitamin D is very important. Vitamin C, excuse me. Vitamin D is a hugely important one. So the active form of vitamin D is referred to as calcitriol, okay? And calcitriol is produced by the sequential action of numerous organ systems. So it's going to kind of start in terms of the skin. It's going to have various different functions throughout the liver and the kidneys. So it's really kind of the sequential action of the skin, liver, and kidneys that are going to create calcitriol. And you're going to discuss that development in these various organ systems in other blocks. But what we want to talk about here in terms of calcitriol is that it can play a big role in terms of increasing blood calcium levels. Okay, so increasing blood calcium levels. And it can do this by increasing calcium absorption by the small intestines or the kidneys, or calcium resorption from the skeleton, so releasing calcium as well as phosphate ions from the reservoirs that occur in bone. So vitamin D and its active form calcitriol can play a hugely important role. Now, let's get into the fun stuff. Let's talk hormones now. And we're going to start with calcitonin. Sometimes you hear it just abbreviated to CT, which is not the same thing as that similarly named calcitriol that we just talked about a moment ago. So calcitonin, calcitriol are very different structures. So calcitonin is a hormone. It is going to be secreted by the endocrine thyroid gland. The thyroid gland is your largest endocrine gland. And calcitonin is going to inhibit bone resorption. Okay, so inhibiting bone resorption, or in other words, it's going to inhibit osteoclasts from breaking down bone and releasing calcium into the bloodstream. So it's really going to, it can play a role in terms of decreasing blood calcium levels. Calcitonin plays a huge role in childhood, but a lesser role when we get into adulthood. Okay, so this is the one that's really going to inhibit bone resorption. Now, parathyroid hormone, or PTH, which is secreted by parathyroid glands that are located in very close association with the posterior thyroid gland. So it's not the same thing as the thyroid gland. And this is really evident in terms of what the hormones do. So whereas calcitonin would inhibit bone resorption, parathyroid hormone will promote bone resorption and thus increase blood calcium levels. Okay, so they have opposite roles, basically, in terms of the hormones that are secreted by those very closely associated glands. All right, so PTH will promote bone resorption by osteoclasts, which will allow calcium to be released into the bloodstream or into as well as inhibiting collagen synthesis by osteoblasts. So it can actually inhibit bone deposition. It also has, as you can see here, important roles in terms of the gastrointestinal and renal systems, and there'll be more to come on that. But really, these two hormones play very opposite roles in terms of what will happen with blood calcium levels, or whether osteoclasts are going to be inhibited or if they're going to be promoted. All right. So that balance is really important. It's a delicate balance, but that balance will play a role in terms of just making sure that the appropriate blood calcium levels are present in the body. Okay, other hormones can play a role in bone growth and remodeling, but they're not playing quite as huge a role as this does throughout life, but they can play really big roles at certain periods of life. So one of these examples are going to be sex hormones, such as estrogen and testosterone, both of which can stimulate osteoblasts. So particularly in terms of time where there is bone length growth. So it's going to play a really important role there. So it can promote osteoblast activity into adulthood. It also can play a role in terms of bone remodeling throughout life. Now, human growth hormone, or HGH, is going to be a hormone that's secreted by the pituitary gland. It really just plays a role in terms of general growth of all body tissues. So obviously that includes bone as well. So I thought I would mention that here. Other factors can affect bone growth and remodeling, like exercise. Weight-bearing activity can really stimulate osteoblasts in that aging process to change. But also bone remodeling, generally osteoclast activity tends to outpace osteoblast activity. So you really need to work through methods that will increase osteoblast activity, such as weight-bearing activity. So to really keep away from having that decreased bone mass with the inequity of osteoblast and osteoclast activity. All right, excellent. So those are the big picture concepts that I wanted to get across regarding bone, or what's affecting bone. So let's review a question. All right, so if blood calcium levels are low, which hormone may be secreted in order to maintain homeostasis? So these are for all hormones. You have calcitonin, human growth hormone, PTH, or testosterone. And really, pause the video, try to figure this out on your own. And when you're ready, let's hone in on certain parts of this stem. So it says blood calcium levels are low. Okay, so what needs to happen is that there needs to be an increase in blood calcium levels. And really, one of these hormones will initiate osteoclast activity that will break down bone and allow for calcium that's stored in bone to be released into the bloodstream. And really only one of these is going to do that, and that is C, parathyroid hormone, or PTH. And so this will serve to increase blood calcium levels by initiating osteoclast activity. The others are going to be examples of things that will play a bigger role in terms of bone growth. It can initiate osteoblast activity. But PTH is really the major one in terms of functioning to hopefully keep at homeostasis if blood calcium levels are low, to cause for blood calcium to be released into, or cause calcium to be released into the bloodstream. And that can be a good thing. You want that. You need calcium in order for, say, muscles to to contract appropriately, or for neurons to be able to communicate with one another. So that's a very natural, important thing. It's when you have too much osteoclast activity without that kind of even osteoblast activity as well. And that's where you get out of homeostasis. And we'll talk about a few examples of that in upcoming videos. Okay, excellent. So these are all really cool things that we are introducing here. And in certain cases, particularly some of those hormones, they'll come back in later portions of the course as well when you get to those organ systems. I want to thank you for your time and attention. And as always, please reach out if you have any additional questions.